Okay, fine. Now this is the way you can create a thread. Normally, suppose, sorry, control C. In a other way, how can you create a thread is, suppose first create an object for this, right? What is that object? Thread 1. For the thread 1 class, you have to create an object. So thread 1 equals to, suppose thread 1 t equals to new thread 1 of, right? This is the way you can create an object normally, right? Now you can pass the t object to this thread class. This thread is a predefined class. You can use that to create your normal class into a thread. Your normal class into a thread you are doing in this way of approach. In before what I am writing is simply I can write a new thread 1. What is the context here? The same thing I can place it here. The same. This is same and before one is also the same. Both are the concepts are the same, right? So simply the class object you can pass to your thread class. Then t1 becomes a thread. Then 3.1 becomes the thread. Run the Java. Okay, both can be work concurrently, right? Both can be work concurrently. Fine. This is the another way of thread creation. And other way is there. It is using a lambda methods or the lambda function. That means simply you can create here. Okay. Suppose thread t3, suppose thread 3t equals to new thread of, okay, new thread of. This is the way you can create a thread, right? Here you can call a method. Here you can call the method. Here you can call the method. That means what are the tasks you have to be, you are intent to be performed, you can write here. Suppose the same task what I have here, right? Here it will be print capital letters, right? I can go with the small letters. Okay. The same thing. Control V. Okay. I can go with the small letters. For that small letters can be start from the 97, right? And end at 97 plus 26, 103, 123. Right? The same, but you have to be start the thread. Okay, start the thread. Run Java. Completed. Your task is completed. You can get an output, right? Where it is. Observe here what I am getting. Small letter, right? And capital letters. 3 tasks can be concurrently working. If you observe the count, before the thread start, count is 1. After the threads, count is 4. After the thread, count is 4. This is the another way. This is the another. Suppose you want to know the names of your thread. You want to know the names of your threads. We have some methods have. Okay. The methods are, you see the 3 ways of creation of the threads, but every thread can be start with a start method. Okay, and we have some names. That means methods. Get name to know the name of your thread, and set name to set the name to your thread. Okay. Next, get state. Thread has the life cycle states. First you can know thread life cycle stages. one thing is first stage is new. That means when you are creating a thread. When you are creating a thread, the thread state is new. Next, runnable. Okay, runnable. It is when you start your thread, the state of your thread is runnable. Next, blocked or waiting. Okay, waiting. Suppose sometimes your thread can be in a wait state. Okay, that means suppose waiting for the another responses. Suppose when you are dealing with a payment, you are needing a confirmation from your bank, right? So in that scenario, the thread can be sometimes in a waiting state. Okay, and the waiting state you can observe in the next session. Okay, why? Because we are dealing with the synchronized things, then you can understand. And another thing as a blocked, and other one is a terminated. These are the 5 life cycle stages of your thread. Terminated means suppose when the thread state has to be completed, then it is in a state of terminated. When the thread work is completed, it will be in a state of terminated. Okay. For knowing the state of your thread, the get state method will helps to you. Okay, get state method helps to you in which stage you are of your thread. It will be helps to that, right? And sleep is one method. Okay, sleep method helps to make your thread into a sleep mode for some time. Okay, and join is one method. Normally threads can be work in a concurrent way, right? You have to be convert your threads into normal programming execution. That means after completion of the thread 1 only you have to be execute the thread 2. Then join method helps to do that. Okay, and these are the main, and we have some methods of wait. Okay, notify all. These methods we can see in the tomorrow session. Why? Because these are can be do with a synchronized manner. Okay. Join. Some other we already seen, right? Active count. It will be tell the how many active threads in your how many current active threads it has your program, and current thread. Suppose when you have a multiple threads, you have to know what is your current thread of the execution. Then current thread is the method to do that. Okay, we can see these names. Okay, fine. I think suppose if you check the name, right, first here I can know the name. Okay, how can you know the name? Is thread is the main class. In the thread you want to know the current thread. Okay, current thread. This method what it will do is it will tells which is the current thread you are. Okay, current thread dot get name. Okay, fine. Thread dot current thread dot get name. Thread dot current thread means in a bunch of thread, what is the current thread you are. Okay, the same I can control C. I can use here also. Okay, normally it will takes the names of thread 0, thread 1, thread 2 if you are not setting any names, default names. These are for the T1 it will takes as a okay, for a T1 it will takes what is the first thread. It will be a thread 0, thread 1, thread 2. That means it depends on the starting of your thread. which can be start first, it will be depends on that. I can run it, right? Thread 0, okay, it's not 093, thread 0. That means first thread 1 will becomes the name of thread 0, and you can observe the thread 1, okay, it is a thread 2. Thread 2 is a small letters printing. That means we are creating one thread by using a what it is, lambda method, right? That thread, and thread 1 is there. Thread 1, no thread 1, yes, thread 1. Thread 1 prints the capital letters, right? This is the default names. Suppose you have to be set the names to your thread. Suppose you are intent to set the names to your thread, then you can set it, right? Here thread dot active thread, current thread, right? Thread dot current thread dot set name. Okay, you can use the set name. You can pass the name. Suppose here I want to print what it is, what name I can print. Okay, numbers. Okay, numbers is the thread name, number space, and the same I can set the name to this thread, set of capitals, okay, uppercase, upper alphabets, okay, upper alphabets, and in the same here also thread, right? Control V, set lower alphabets, fine. Now if you run this, you can get the names of what I am set it to that, right? Numbers 91, 92 like that, and the lower alphabets and the upper alphabets, we have upper alphabets, okay. These are the things. And sleep, right? Sleep means suppose you want to sleep a thread for a while. I can show to you first. Suppose if the sleep method wants to be understand, then I'll do. After execution of this thread, or else for the every number printing, thread dot sleep, okay, thread dot sleep of I can take it as a 2000 milliseconds, okay. It will throws an error. The error is normally how your threads can work. It will be executes in a milliseconds of time and the concurrently. But what you are doing, you are stopping the execution of your thread for some time. So it will raise an exception of interrupt exception. So you can write or you can use here I can use, it is a main, right? So or else you can use try, okay, try block. In a try I can write try, and in the catch block I can write the exception of interrupt exception, right? Interrupt exception E, simply E dot print stack trace, It is a one thing. For a while I'll do the thing of I'll commented these two, okay. I'll commented the T2 and the T3, okay. Then you can understand the sleep. If I am not commented T2 and T3 running concurrently, you can't find that difference of the sleep, right? So for that 0 1 2 1 2 1 2 1 2, after every 2 seconds it will be printing the things, right? Now it will take to print the 100 numbers, 100 into 2, that means 200 seconds, it means 3 minutes. In a meanwhile it will be runs in a 2 or 3 milliseconds of time, right? But you are maintaining in a sleep mode and right, the thing, right? So we can't stop that, right? We have to terminate that. So wait for the 2 minutes. Oh, 65, right? Fine. This is the sleep method. Suppose you want to make one thread into a sleep. Some scenarios can be erasing. You have to make your thread into or your activity for a while, making into a sleep mode. In such scenarios, sleep method helps to you. But you have to be understand when you are writing a sleep method, which exception can be erased. Interrupt exception. Why? Because the task which has to be performed in a milliseconds of time, you have to be violate it. You are violated. So you are telling to your compiler, I am intentionally do that, so allow it. That is the thing. Okay? Yeah, 96, 97, 98, 99, finish. Right? It is the sleep. Suppose I can show with the thread 2 and the thread 3 the join method also. For a while, instead of 100 printing, I can go with the 10 numbers. Okay. Then it will be take 20 seconds, right? Or else I can take I can remove the sleep into the 1000. Then it will be 10 seconds. I can uncomment these threads now, but first I have to be execute. First I have to be execute your T2. You can do one thing. Concurrently, we can check the state. We can check the state of our thread and also make the join also. Suppose here you are creating the threads, right? Here T1 creating, T2 creating, 3T. Fine. Suppose here you can print sys out of thread 1 state before start. Okay, thread 1 state before start. It is a T1 dot get state. Okay, get state. Okay, T1 dot get state. Like the same way, write for the every thread, right? Then you can understand the thread states. Thread 2, this is thread 2, and T2. Okay, T2, and here also you can understand 2 threads run, then it will be fine. After starting of your thread, state thread 1, sorry, thread 2 state after start. After start, like the same way, thread 1 state after start. T2 and T1, right? Fine. But now what I have to do is, after the completion of T2 execution, that means thread 2 task completion only, after completion of the thread 2 task only, I am intent to start thread 1. Then how can you do that is T2 dot join. Okay, T2 dot join. Interrupted exception, fine, I can write throws class. Throws, what is that exception? Interrupt exception. Why? Because normally your thread has to be performed concurrently, but you are making it to a different behavior. So write that interrupt exception, then it will be allow. Right? Now you can run. You can observe the difference of how it will be run. Okay, first it will do, what is the task is this? It is a thread 3. Okay, thread 3. So thread 3 first run, and after completion of the thread 3, your thread 1 will be start. Normally your T1 start here. Okay, numbers printing, but it will be takes 1 second for the every printing, right? In the 1 millisecond, in the 1 second of time, your completion of the thread 3 task will be done, right? Next, it will be go with the T1 only. It was go with the T1 only. So it will printing the number 1, number 2, number 3, right? What it not execute? Thread 1, thread 2 not executed, right? Do the thing. T2 dot join, because of the T2 dot join, right? So control C. T1 dot join. Or else after, right? T2 dot join. Before start you don't. T2 dot join. It will printing the first alphabets, upper letters also printing, right? Upper letters Y, upper letters is, I am writing the T2 dot join. That means first you can check with the states before, after creation of the thread, not before the start. That means before the start your thread state is new, right? First state, when you are creating a thread, the state of the thread is new, right? After starting of the thread, the state of the thread is runnable. Okay, and which it will be start first? T1. What is the T1, right? T1 it has to be start, but wait, T1 dot start, right? So what is the T1 task? T1 task is numbers printing, T2 task is capital alphabets printing, 3T task is small alphabets printing. Okay, first it will be print with the upper letters. Okay, first it start with the upper letter, that means it will be thread 2. Next it will be with the T1. Okay, T1, fine. After completion of the thread 2 will be completion, right? Next it will be timed waiting. Okay, timed waiting state, that means you are arranging into a sleep mode, right? You are arranging your thread 1 into the sleep mode. So at that moment it will checking the state. So that state is time weighted of your thread. Fine. Next, after thread starts 3, okay, it will be printing the active thread count. One thread is vanishes. What is the thread? Printing of upper letters. So it will be count becomes 3, and it will be prints the lower letters. After completion of the lower letters, it will be start printing of numbers. That means which you are writing. Suppose if here I can write the t1 dot join or t2 dot join, right? So t2 dot join, what it will do is it will do, that means after starting of the t2, which will become, it will be completion at the last. Suppose in a two things, fine. For a while I can take Ctrl C. Okay, t2 dot join, t1 dot join. Here my thread will be start till to the completion of the t2. Your t1 not start. Why? Because you are making into that synchronous. That is the you have to be remember. When you are making a join, you can make the things can be run in a synchronized manner. It is by using a join, right? And you already know the how to set the threads, right? By using the set name. You can set in the threads, or else you can set here. Where you can set here means you can set here t1 dot set name. Okay, t1 dot set name. By using here also you can set t1 dot get name. Here also you can get. But you have to be do in the thread. You have to use the thread dot current thread dot get name or the set name. But in a lambda type of thread creation, you can set the thread names here. That means passing into the constructor. Suppose here I can pass like lower. Okay, lower. Then lower will be that thread name. Observe that lower will be the thread name. Fine. Runnable. Fine. That is the methods you have to be remember, and we have some other methods. Those are we seen these 5 methods, right? We have other methods of, we already seen that active count and the current thread, and we have the wait method. Before that wait method, we have the set priority, get priority. That means by using this you can set the priority for your thread. That means which thread can be executed first, which thread can be executed next, which thread can be executed after that. Okay, but we are not assured that your scheduler means your CPU will be maintains that order. Sometimes it will maintain, sometimes it will not, depends on the task execution time. Okay, notify all. And what the things we have to be discussed is, one was race condition, and another thing is synchronize. These can be, we can discuss in a next session. Race condition is nothing but, suppose some are withdrawing the money from 2 different ATMs. Okay, from 2 different ATMs, try to withdrawing the money. One can be do by using the card, one doing by using a QR pay. Okay, you can ask like a doubt. One account has only 2 ATM cards, right? Single ATM card, right? There is no 2 ATM. So because of that I am telling that one withdrawing the money by using a ATM card, one withdrawing by using a UPI QR. Okay, from on my same account. Suppose my account containing the balance of 1000 rupees, 1000 rupees, both are doing concurrently at a time. Okay, concurrently at a time. Suppose who are doing with the ATM card taking as a person 1, who are doing with the QR pay taking as a person 2. Person 1 and person 2 first check my balance. Both can see the sufficient balance to withdraw of 1000 rupees. Both are intent to withdraw the 1000 rupees. Okay, both are seeing the balance of 1000 rupees, but both are doing the concurrently, right? Withdraw, that means my account has only one withdraw method, right? So they are performing on the same variable or the same method. That means which is my account balance. Person 1 also try to withdraw, person 2 also trying to withdraw. Suppose in the first scenario both can be enter into that withdraw method at a single moment. That means in the first condition what it will check, what was the he or she trying to the money withdraw, the money is sufficient to withdraw or not, right? Right, but both the conditions will be true, right? Why? Because both are entering in the same time, both can observe the my balance, both can observe my balance. So in such scenario, one transaction will be success, another transaction is also be success, right? Then who can lose the money? Bank can lose the money, right? That is the concept of race condition. One resource can be accessing by the two or more threads at a single moment. There will be a possible for the miscalculations. In such scenarios, how can you handle it? By using the synchronized. That means we can maintain a lock. Suppose one thread can be enter, you can maintain a lock until the thread operation has to be completed. That by using a synchronized we can see in the next session. Fine. First you have to be understand how can you create a thread, how can you run the thread, what is a thread, and all the things. How can you set the names to your thread, and how can you getting your names, and how can you maintaining the joins, and how can the sleep method will be executed, and all the things you have to be understand. Then we can go with the tomorrow we can go with set priorities and all the things, and also wait, notify and all. Wait, notify are nothing but we are using the synchronize. In that synchronize method we are using this wait methods and the notify and notify all methods. We can discuss these 5 the next session. These are the advanced topics in a multi-threading. Okay, thank you.